Welcome back, ladies and gents. Let's get down to it. This is the last video, or last section of chapter 1, but we're going to split it into two videos. Talking about absolute value equations today, and then the next one we'll talk about inequalities. So this is still the same Common Core State Standard, ACED1. Create equations and inequalities, one variable, and use them to solve problems. Okay, so an absolute value equation looks like this. We have the two absolute value marks, which are these. They kind of look like parentheses, but they're not. They're straight parentheses. So when you're solving an absolute value equation, we have to, it's kind of like solving a regular equation where we isolate the variable, but in this case we're going to isolate the absolute value. So we have absolute value of x plus 2 equals 9. So first we need to isolate the absolute value, which is this guy. So we have to subtract 2 to get rid of the 2. Then we get absolute value of x equals 7. Okay, but absolute values almost always have two solutions because absolute value is just a distance from 0. So what number can you plug in for x that gives you a distance of 0 or distance of 7 from 0? Well, that means x could be positive 7 or x could be negative 7. So whenever you have the absolute value alone, you next just set up two equations, one with a positive and one with a negative. And that was pretty easy because it was just x inside the absolute value. Okay, so that's our solution. And then it wants us to graph the solution, which means if you just make a number line, I'm going to put 0 here, 7 there, and negative 7 there. We will estimate 1 point on 7, 1 point on negative 7. And they are equidistant from 0, see? Same distance. Okay. Then if you check your solution, if you plug in absolute value of 7, that gives you 7 plus 2 is 9. Absolute value of negative 7 is still positive 7 plus 2 equals 9. Alright. Okay, you guys try this one. Basically the same concept, so pause this and try it in 3, 2, 1, pause. Welcome back. So you added 5 to both sides, and you got absolute value of n equals 3, which means n could be positive 3 or it could be negative 3. So we have two solutions. Plot those on a number line. We just put a point at negative 3 over here and a positive 3 over here. And if you notice, those are both 3 units away from 0. And then you can plug it back in and check. Okay. So then we get some more difficult equations that have more than just x on the inside. So on this one we have 2x minus 5, the absolute value, equals 13. And this is the equation. Absolute value of 2x minus 5 equals 13 means the distance on a number line from 2x minus 5 to 0 is 13 units. There are two points that are 13 units from 0, and that's positive 13 and negative 13, like we were talking about before. So we're going to have two solutions there. So you have to set up two equations. 2x minus 5 equals positive 13, and 2x minus 5 equals negative 13. Okay, so whenever you have the absolute value of a number, you just equals to some other number. You set it equal to the positive version and to the negative version. Alright, so let's look at that. Okay, so in this one, it says starting from 100 feet away, your friend skates toward you and then passes you. She skates at a constant speed of 20 feet per second. Her distance d from you in feet after t seconds is given by the equation d equals absolute value of 100 minus 20t. At what time is she 40 feet from you? Okay, so we can set up the equation here. D equals absolute value 100 minus 20t. And we want to know when she's 40 feet from you. So 40 feet is going to go in for our distance. So let me just replace that there. D with 40. So when does the absolute value of 100 minus 20t equal 40? So again, because it's an absolute value, it can be two different scenarios here. We can have positive 40 or negative 40. So set up the first one, 100 minus 20t equals positive 40. And then the next one, 100 minus 20t equals negative 40. Okay, and then I just have to solve both of them. So what I like to do with these is just solve them at the same time because you're basically doing the same steps. So I subtract 100. It's not 1,000, 100. Subtract 100, subtract 100, subtract 100. So on this equation, I'm going to get, those cancel. So I get negative 20t equals negative 60. On this one, I get negative 20t equals negative 140. And then the last step, I divide by negative 20. And I can do that on this one too. It's kind of handy. These cancel. Ka-chow. T equals negative 60 divided by negative 20 is positive 3. Ka-chow. Those cancel. T equals, it's going to be positive 70. 70, that's not true. 7. T equals positive 7. And that is in time, so that's in seconds. Okay, so that means that she is 40 feet from you at 3 seconds and at 7 seconds. So at 3 seconds, she's probably behind you because she's passing you because she's faster than you. And at 7 seconds, she's 40 feet in front of you. Okay, 40 seconds behind, 40 seconds in front. That means in 4 seconds between these two times, she went 80 feet. Crazy, 20 feet per second. Okay, so we got a new equation now. 80 minus 5t equals d. So if you look back at the previous one, it was 100 minus 20t. So if you think about it, your 100 represents how many feet away your friend skates from you. Okay, so she was 100 feet away. She started at 100 feet away, and she was going 20 feet per second. So she's getting closer to you. So your distance is decreasing because she's getting closer to you at 20 feet per second. So if you look at this next one, we have 80 minus 5t. So 80, what does 80 represent? And what does the 5 represent? Okay, so in this case, 80 is going to represent how far she is away from you, and 5 is going to represent that she's going 5 feet per second towards you. Okay, so it's changed a little bit. She's gotten a lot slower, actually. Maybe she's tired, I don't know. Anyway, at what point is she 60 feet from you? Okay, so go ahead and set up the equation and see if you can solve it, and we will go over it after we're done. Okay, pause this in 3, 2, 1, pause. Welcome back. I got 4 and 28. So I set it up to positive 60 here, negative 60 here. So at 4 seconds, she's 80 feet behind you. At 28 seconds, she's 80 feet in front of you. Okay. Hopefully you all got the same. We're all on the same page, same boat. Okay. Recall that absolute value represents the distance from 0 on a number line, and distance is always non-negative, meaning it's always positive, or I guess it could be 0. It's never negative. So any equation that states the absolute value of an expression is negative has no solutions. Okay, so that's a little insight on what we're going to do next. Okay, so we have this equation here. Now this one is a little bit more in detail, in depth. Okay, so right now our absolute value is not isolated. See, this part is what we want to get isolated. So first thing you need to do is get rid of the 3 and the plus 12. And just like a regular equation, we're going to do that from the outside in. So we're going to subtract 12 first from both sides. Those are going to cancel. Then we get 3 absolute value, 2z plus 9 equals negative 2. And then this 3 right here we can't distribute because your absolute value is not the same as parentheses. So instead of distributing, this is 3 times the absolute value. So we're just going to get rid of the multiplication by dividing. So divide by 3, divide by 3. Those cancel out. Ka-chow. And then we get absolute value of 2z plus 9 equals negative 2/3. But remember, absolute value can never be negative. So this part right here cannot equal a negative number like this. Okay? So what a lot of people do is they forget about that, and then they just immediately go from here to setting up two equations. 2z plus 9 equals positive 2/3, and 2z plus 9 equals negative 2/3. Okay? That is not right. So at this point right here, you can just stop and say, we know that this absolute value will never equal negative 2/3. There's nothing you can plug in here, because absolute value is always going to change it to positive. So at this point, you can stop. We're not going to do any of this, because we know it's pointless, because absolute value can't be negative. And we're going to say there's no solution. no solution. Okay, or you can also write the symbol, or you can say null set. Any of these things work. Okay, so whenever your absolute value, so the whole absolute value piece equals a negative, it's no solution. Okay, so you don't even have to set up the two equations. If this was a positive 2/3, right, at this point, then you would go ahead and set up the two equations, or 2z plus 9 equals 2/3, and 2z plus 9 equals negative 2/3. But because it was negative, it is indeed no solution. Okay, so you go ahead and try this one. And I will do it as well, and then we will compare answers. Okay, pause this in 3, 2, 1, pause. All right, so I just added 5 to both sides, and that still left me with a negative 2 over here. And because absolute value cannot be negative, we get no solution. Okay, oops, I put solutio. Solution. Yeah, so this is going to be no solution, and because it cannot equal a negative. So this absolute value part right here cannot equal negative. So we're not going to write the two equations. We're not going to say 3x minus 6 equals positive 2 and 3x minus 6 equals negative 2. We're just going to say this is no solution because absolute value can never be negative. Okay, and that is all we're going to do for today. So in the next video, we'll talk about absolute value inequalities, which is the stuff we did in the last two videos in section 1.8. And then that will be the last one. So after that, we'll do the review and then the chapter 1 evaluation. And then we'll be done with chapter 1. We're just cruising right along. Okay, make sure I don't remember if there's two quizzes for this or one, but I will check, and you should check on Canvas, see if there's 2 1.9 quizzes. I'm going to check right now. But like the 1.8, there was only one quiz that covered both videos, so it may be the same for this one. Yeah. Okay, so again, this is no solution. And yeah, I'll see you guys in the next video. Adios. Peace out. Make good choices.